July 27, 1944. Near Saint-Denis-le-Gast in Normandy, a German 88mm shell slammed into the side of an American Sherman tank. The round screeched through the armor, tearing metal, and for the Panther crew that fired it, this was supposed to mean one thing: death for all 5 men inside. The gunner from the 2nd SS Panzer Division, Das Reich, held his breath and waited for the familiar fireball. That was how it always went. A successful penetration meant flames erupting out of the turret, ammunition cooking off, and a Sherman transformed into a burning coffin. But this time, something was wrong. No flames, no catastrophic explosion. Instead, the Sherman's turret swung around, its 76mm gun slowly traversing toward the Panther. Inside the German tank, confusion set in. Their loader, already reaching for another shell, froze. Every training manual, every hard-won lesson from Russia and North Africa, every intelligence report told them the Sherman was supposed to ignite when hit. And yet here it was, still alive, still fighting. What they were witnessing that morning was not just a fluke of survival. It was a revolution in tank warfare. The Americans had quietly rolled out a modification that the Germans had completely missed. This Sherman was an M4A3 with wet stowage ammunition. Instead of shells stored openly inside the fighting compartment, the ammunition was sealed in double-walled bins surrounded by liquid, nearly 38 gallons of it. This chemical solution acted as a fire suppressant, smothering sparks and hot fragments before they could ignite the propellant charges. Before this system, 60 to 80% of penetrated Shermans erupted into flames. With wet stowage, that number plummeted to just 10 to 15%. That morning in Normandy, more than 100 of these modified Shermans from the U.S. 2nd Armored Division rolled into battle. The Germans had no idea. Not a single intelligence briefing, not one field report, not even rumors had reached them that the American tank, the one they had learned to exploit, had fundamentally changed. Their battlefield math was now dangerously wrong. The story of this hidden advantage began long before Normandy, in the desert of Tunisia. February 1943, the Battle of Kasserine Pass. American armor lay wrecked across the valley. Shermans knocked out by German 88s and Panzer guns burned with horrifying regularity. In that battle, out of 300 American tanks engaged, 183 were destroyed. Most of those losses weren't from broken engines or immobilization. They were fireballs that consumed the crews inside. British researchers documented that 65% of destroyed Shermans burned completely. American studies put the number even higher, closer to 80%. It was a slaughter, and it wasn't gasoline that caused the problem. It was the ammunition. Sherman tanks carried more than 70 rounds of 75mm ammunition in racks spread throughout the crew compartment. When a shell or fragment pierced the armor, it hit those propellant bags, igniting them instantly. The interior became a furnace. Survivors were rare. The U.S. Ordnance Department knew something had to change. Engineers studied wrecks, dissected burnt-out hulks, and looked for solutions. One breakthrough came almost by chance. At a tank board meeting in late 1943, a chemical engineer from DuPont suggested a radical idea. Why not surround the ammunition with liquid? At first it sounded absurd, impractical, even dangerous. The early versions proposed filling entire compartments with water, like turning the tank into a submarine. But through trial and error, the concept evolved into something elegant. The ammunition would be sealed in double-walled containers, and those walls filled with liquid fire suppressant. By January 1944, the first M4A1 and M4A3 Shermans with wet stowage rolled off American assembly lines. Tests at Aberdeen Proving Ground proved the system worked. German 75 and 88 mm guns were fired at both dry and wet ammunition racks. Dry racks erupted in massive fireballs nearly 3/4 of the time. Wet racks? Only 15% of hits resulted in fire, and even then, the flames were small and quickly extinguished. The chemical solution inside the bins was called Amudamp, a mixture designed to prevent freezing in winter, resist corrosion, and stop bacterial growth. It was clever engineering, a liquid that worked at -40 degrees Fahrenheit and still suppressed flames better than plain water. The modification added about 900 pounds to the tank, but the trade-off was worth it. Crews now had a fighting chance. By April 1944, more than 100 of these new Shermans had arrived in England. Assigned to the 2nd and 3rd Armored Divisions, they missed the initial D-Day landings but entered combat during Operation Cobra, the American breakout from Normandy in late July. It was here that German crews first began noticing something strange. Their Panthers and anti-tank guns were still achieving penetrations, but Shermans weren't burning like before. Many were driving away after being hit. Others returned to action within days after quick battlefield repairs. For German intelligence, it was a nightmare they never even realized was happening. The truth is, German tank crews had been trained to target specific weak points on Shermans, locations where ammunition racks were stored in earlier models. Their manuals, range cards, and classroom instruction all emphasized these kill zones. But with the wet stowage redesign, those vulnerable areas no longer held ammunition. German shots hit, penetrated, but often failed to ignite anything. Frontline tankers reported this to their officers, but higher command dismissed the accounts as exaggeration or stress-induced errors. The doctrine was too ingrained and the German intelligence system too fractured to adapt. Meanwhile, American industry embraced the change with astonishing speed. Factories like Fisher Tank Arsenal in Michigan and Pressed Steel Car Company in Pennsylvania retooled entire production lines without halting output. Thousands of wet stowage Shermans rolled out between 1944 and 1945. By summer, nearly all new U.S. tanks carried the modification. The Germans, however, continued fighting as if every Sherman was as vulnerable as it had been in 1942. The results were staggering. During Operation Cobra, American maintenance battalions recovered nearly 70% of knocked-out Shermans. Tanks that once would have been total losses were patched up and sent back into battle. German planning, which assumed permanent destruction rates based on old data, now consistently underestimated American strength. Commanders thought they were facing shattered, weakened spearheads, only to be counterattacked by armored units at full strength. By the fall of 1944, the effect was undeniable. At the Battle of Aracourt in September, the U.S. 4th Armored Division faced off against the newly formed German 113th Panzer Brigade. Panthers and Panzer IVs scored dozens of hits on Shermans, but the Americans didn't collapse. Out of 151 Shermans knocked out, only 41 were total losses. The other 110 were repaired and returned to service, most within a week. German staff officers counted all 151 as destroyed, completely misjudging American resilience. This advantage carried through the rest of the war. From the brutal fighting in the Ardennes during the Battle of the Bulge, where African-American crews of the 761st Tank Battalion kept fighting even after their tanks absorbed multiple penetrations, to the final push into Germany in 1945, Wet stowage kept American crews alive. In battle after battle, it multiplied American strength simply by preventing catastrophic losses. What's truly remarkable is that the Germans never caught on. They captured wet-stowage Shermans, even operated them for short periods, but never realized what had changed. Their intelligence agencies were fractured, underfunded, and focused on desperate wonder weapons by 1945. The subtlety of the modification, a hidden liquid inside ammunition bins, escaped them completely. Not one German after-action report, not one technical bulletin, not even post-war memoirs mention it. In the end, this quiet innovation may have saved more American lives than any other single-tank improvement of the war. Studies after 1945 showed that while older Shermans burned in up to 80% of penetrations, wet stowage reduced that to just 10 to 15%. By conservative estimates, the system saved more than 5,000 crewmen who would otherwise have died in fire. More than that, it preserved American armored strength in battle after battle, accelerating the collapse of German defenses. The story of wet stowage is one of those rare wartime tales where an invisible change had an outsized impact. It didn't make headlines, it didn't change the silhouette of the Sherman, and it didn't require new tactics. Instead, it quietly tilted the balance of survival. Battle after battle, until Germany's war machine found itself fighting an enemy it no longer understood. German tankers continued to fight with outdated assumptions, aiming at the wrong weak points, relying on outdated intelligence, and discovering too late that the rules had changed. The Sherman wet stowage system didn't just save lives, it shortened the war. In this hidden edge, multiplied across 1,000 battlefields, lies one of World War II's most remarkable but overlooked stories. The simple, invisible modification that changed everything.